those things you have missed it, so it's just gonna be loading. Yeah, I'm a techie teacher. Just loading. All right, so that's being loaded there at YouTube. I will share the YouTube link. You can watch it later, okay?
Okay.
Cool.
Thank you.
All right, guys. Let's moving back to fx minus 3. Boundary, what did you get for x? Fx is minus 3. What did you get? X equal to 0. So we're going to roll minus 3 nicely here. When you do minus 3, minus 3, minus 3. So thick line. So I can't really see anything. So minus 3. It's a minus 3 line. So minus 3, it's 0, and then 2. So that is going to be x equal to 0 and x equal to 2, isn't it? Okay, cool. And then going back to you, sir, Hillman, what did you get for the last one, sir? Fx equal to 0.
Oh, I was still doing B.
Oh, you're doing B. Okay. So can you just do the last one, Steve?
Yes. It's x equals -1 and x equals 3.
Sorry?
X equals -1 and x equals 3.
For minus 3. Sorry, last one, fx 0. What did you get?
X equals -1 and x equals 3.
Yes, so that's right. X equal to -1. X equal to -1. And x equal to 3. Okay. So now we're
Wait, so you don't have to do it algebraically?
You have to do algebraically. You need to factor it.
Yeah.
So I'm expecting you should know how to do factoring. Oh, just how to find a graph? The last one? Okay, so let's say fx equal to 0. Fx equal to 0, I mean y is equal to 0, right? So y is equal to 0, I mean x-axis. So if I'm going to draw the x-axis there, where my x-axis, oops, that's too big. Where do you think my x-axis crossing the graph? It's crossing the graph here, crossing the graph here, isn't it? You see that? So we list those points. That's -1, and this is 3. For example, -3, I draw the graph, and the graph crossing here, so we just label that, right? 1 and 2. Make sense? All right. So now going back to A and B. Can you just figure out A and B by yourself? Try it. I'll be back. And if you guys want to use the washroom, right beside the elevator. So there's a corner side of the elevator. You'll be in C. All right, let's see how that's going, that question. So I'm gonna need to figure that out. Done? No idea? Yes, first one is pretty straightforward. Did you guys do that?
Yeah.
Yes, what do you get for f at 5, Barnaby? F at 5 is 0. F at 5 is 0, yes, that makes sense. What do you get for g at 5? Negative 19, so that makes sense. 0 is greater than negative 19, prove, isn't it? The last one is a little, well, easy. So 2 times g at f of a. So it's going to be 4 minus 3 times 4a, isn't it? So we have to make sure to put a bracket 2 times 4 minus 12a, which is going to be 4 times 2, 8 minus 24a. Make sense? Stop a second. What did you get? We replace the x by 4a. So x, 3 times 4a is 12a, 4 minus. Did you get 4 minus 3, 1? What did you do? You're racing your work. I want to see. What did you get? Let's see where things went wrong and what the algebra is. So 4 minus 3. Oh, you separate the 3 times 4 and then 8. You see that wrong algebra? Okay. Well, there's a lot of work how to do on the algebraic skills, right? So especially in your school, I think the grade 12 teacher told, as we have high standard, I mean, tests are going to be harder than the other schools. I'm not sure. Did they tell it? Okay. So if you're not refreshing your basic algebraic skill, then there will be a trouble. Are you guys following that? So for a second? All right. So now what we're going to going back to, guys, is some definition. I'm going to go back to write it. So this is going to be on my notes. My notes continue. We're going to talking about the next part is, I think just make sure my textbook, I'm aligned with the textbook. So you guys going to do 1.2 function notation questions. We did pretty good amount of questions, so you should not have a problem to work with the 1.2. So you can play around 1.2, pretty straightforward. Exploring properties of parent function. I'm just gonna going back to, okay. Asymptote, okay, so okay, so I'm gonna go back to 1.4. So we're gonna define some key terminologies, which is the neurocaret, record that, domain. The domain of a function, so domain of a function, The domain of the function is basically a set of all independent variable. Simple. All x values. Because all independent variable mean we are referring to all x values, isn't it? Makes sense? Independent variable, all x value. So far so good? Okay. The range of a function, a set of all dependent variable. Any question with that? Range is set of all dependent variable, all the y values. So far so good? Okay. Now what we want to learn is, we want to learn set notation. We're going to learn set notations. Now, there are so many different numbers in the number line. So let's see, Bhavnavi, can you tell me one sort of numbers on the number line? So if I take a number line, there are so many different number lines on the number line. So this is 0, this is 1, this is 2, this is -1, this is -2, and so on and so on. So there are so many different numbers in the number line. Can you tell me one sort of numbers in the number line? Well, okay, but I want common name for them, the numbers that you have learned. There's a one common way to tell each different type of numbers. So I will start off with, we have integers, isn't it? Everyone say that? Integers, right? One type of number. So some of them are integers, okay. Can anyone able to tell me integers, what sort of numbers? Any other numbers you have learned? What is integers?
Decimal.
Sure, decimal, okay. So you have a decimal numbers, yes. But I don't want to say it's decimal because we're going to call them with a different name. One is integers. But integers include both negative and positive. How do I just call the numbers 0, 1, 2, 3? What's the name for them?
Whole numbers?
You got it, sir. Grade 9 math, you did well. Whole numbers. Whole numbers are simply 0, 1, 2, 3, and so on, so isn't it? All right. Another type of number.
Real numbers.
We're going to come back to that. Yes.
Oh, rational numbers.
We're going to come back to that. So there's another one. If I don't include a 0, we call natural numbers. So which is basically 1, 2, 3, and so on. So right. All right. Now, other than that, there are numbers. So what Kilman says, 2/3. It's 0.667, isn't it? There are other numbers, 2/3. -1/2. 3.141 ... 2.178 ... So now let's look at these two numbers. This is a simply decimal number or fraction, isn't it? And you can see it's an integer over integer, isn't it? It's integer divided by integer. But here's the problem. Do you think I can write the number integer over integer? 3.411, 3.141. There's no way I can write an integer over integer. Who can tell who this guy is? Who can tell what is the number represent? Yes, sir. Pi. How many of you watched the movie Life of Pi?
Oh, that's the one with the line in it, right?
What?
Isn't there like a line in that movie?
The line. Oh yes, the line in the movie. Yes, they're transporting the line from India to Yasu and Alberta. No one heard the movie Life of Pi?
I don't think I watched it, but I know that.
So it's a movie came out a long time ago. The person who actually acted on the movie, he's a professor at zoology in University of Alberta. It's related to a real story. But on that movie, the professor has actually memorized the digits of pi and then recitate all the digits in pi for fun. Anyhow, that's a pi. But you cannot write pi as something over something, right? So now these two numbers are falling into the category called rational number. Rational numbers. These are falling into category irrational number because you cannot write them as a fraction, right? Now, every numbers you see is what Adam said, known as real numbers. Every numbers, real number. So what does real number actually look like? If you look at the number line, 0, 1, 2, -1, -2. Real number is simply everything on the number line. Every single number on the number line is real numbers. So we got real numbers. So what is the opposite of real?
Wait, so all of those are real numbers?
All of them are real numbers. Integers, whole number, rational number, natural number, rational number, all of the numbers are real numbers. Everything together, real numbers. Check this out, 1 second. All right. Now, what's the opposite of real?
Not real.
Okay, non-real. Is there any other word? Real, real person, fake person, real. What's the other one? Real person, fake person. What's a good way to say? Real person. There's another word. It started I. Yes. Yes. Imaginary. Real numbers and imaginary numbers. Do we have imaginary numbers? We do have imaginary numbers, but you're not going to use it unless that you're going to specialize in going for electrical engineering, computer engineering, or you further do some research on geography, on mathematics. So these numbers are real numbers. The imaginary numbers, any numbers that's come inside the square root with a negative sign. These numbers inside the square root negative, we can't really evaluate. We're not going to work with imaginary numbers at all. But if you're on the AP program or if you're on the IB program, there is a section in complex numbers introduced in grade 12. They will talk about a little bit about complex numbers. Now, what we want to talk about, notations. Notations. So we're going to learn about some notations. So if I just use this sign, you guys see a little R with a slide beside it. This is referring to all real numbers. All real numbers. I mean, the entire number line is the R notation. Z, all integers. All integers.
Wait, is that regular Z?
It's regular C with a little slash on the middle.
Okay.
C plus, all the positive integers. C minus, all the negative integers. I, all irrational number. Q, all rational numbers. W of whole numbers. Least, not, last, and all natural numbers. Now, will I use all of them in grade 11 functions? Absolutely not. Most of the time, majority of the time, you're only going to stick with the real number. This is the one we're going to use it often. Now, we might just talk about the other ones, but we're not going to really talk about all of them. You will only deal with real numbers. Now, something I'm going to talk about a few. So a few more notations. So set is a collection of objects. So set is basically a collection of objects, a set. So example of sets. Example. I can't say set A. I'm going to list 2, 4, 6, 8, and 10. It's simply all the even numbers greater than equal to 2, less than equal to 10. Pretty straightforward. So there's no fancy about that. 2, 4, 6, 8, 10. But I'm going to use some set notation. First notation is element of. Element of. So how do I use the notation element of? If I say 2, I can say element of A. So how do I read this? 2 is an element. It's an element of set A. Now you can see that there are a lot of Greek mathematicians from Pythagoras to Aristotle, right? This is coming from a Greek alphabet E, sometimes known as epsilon. All right, but we use this. It's an E, but it's a cursive E. So 2 is an element of A. Make sense?
Is that 2EA?
2EA, but that E is not the regular E. So you see it's a curvy E.
Yeah.
But if I want to say 1 is not an element of A, then I'm going to put a little cross here. So I will say 1 is not an element of A. 1 is not an element of A. Do you see that so far? Okay. So why we are going to talking about this? I'm going to show you how to list the domain and range for different functions using set notations. So we're going to do some easy one that you have seen before. So let's consider linear relation. Linear relation. I'm going to draw the graph of simply y is equal to 2x plus 4. Well, pretty straightforward curve, y is equal to 2x plus 4. How that's going to look like, y is equal to 2x plus 4. You have an x-intercept of 4, slope of 2, so it's going to be 2 unit, right? So it's going to go like that, right? So this is your x-axis, this is your y-axis. Now, you look at the curve, guys. If you look at the line taking the into x-axis spanning into your y-axis, isn't it? Does everyone agree with that? This line will go forever in the x-axis, forever in the y-axis. Everyone following that? There's no limitation, isn't it? So what I mentioned about the domain I'm talking about the set of x values, isn't it? Now, if my x value is anti-x-axis, that's simply then real number. So we're talking about x values in domain. We say x's belong to a real number. So this is the notation to tell the domain. So how do I state it? X is an element of all real numbers. Simple as it is. X's belong to all real numbers for the domain. I guess follow that?
Yeah.
Okay. So how do you say the range? Well, curly bracket start because set must be in a curly bracket. Y is belong to a real number because there's no restriction there. Y is belong to all real numbers. So far, so good. Someone following that?
Yeah.
Okay, pretty straightforward, the notation. Do you guys understand how to read it? X is an element of all real numbers. Y is an element of all real numbers, isn't it? Now let's going back to a quadratic relation.
Wait, is that the curve, the E?
Curve E, yes, that's a curve E. That is my curve E, that's right. All right, quadratic relation. That's why sometimes certain pens are beautiful to write math notations, because most of the math notations are cursive, if you're going to see it. So we use fountain pens. On those days, all the mathematicians use fountain pens. Have you ever seen fountain pens? You guys have seen fountain pens. Did you guys see fountain pens? Yes.
The ones with like the tip where like.
Yes, that's right. What's that? That's right. So you don't see it, then I'm a fountain pen guy. So this is, I have several fountain pens. So I kind of obsessed with the fountain pen.
Is it harder to use?
Well, the only hardest to use is if I get this pen, thing won't flow. But if I don't use it, thing will flow because it's programmed mechanically the way I write. It's an ink, liquid ink flow through the tip. So the tip is automatically programmed in a specific direction. So this one is a gold-plated tip. Very nice to write math formulas. I'm obsessed with this. So I think that people say that every people have different obeisance. So my obesation is pens, especially fountain pens. Okay, moving back, quadratic relation. So I'm going to sketch a simple quadratic relation you guys have seen before. So let's put this guy as 2, and this is 2. So my quadratic relation goes like this. So this is my simple quadratic relation. This is the x-axis, this is the y-axis. Pretty straightforward. So my question here is, do you think my graph taking every single y values? Do you think this graph will take every possible y values on the y-axis?
Yeah.
So it's sitting here. It is not going down. This graph is about this.
Oh, wait, I was looking at the dotted line.
Okay. The smooth curve.
Oh, no.
Does a smooth curve take every possible y values? No. But does a smooth curve is different for every possible x values? Look at this. If I extend this graph, it's going forever, I can still find some values when I extend it, isn't it? Are you following that? So if I extend the graph, I can still find some values. Make sense? Okay. So now
Okay, so would it be able to do every single x value?
That's right.
Yeah.
It's so the domain is going to be every single x values. The domain x belong to real. There's no restriction on that. But when it's come to the range, we have a problem. So why do you have a problem? We're talking about a y values, isn't it? So now what we're going to do, guys, we're going to state restriction. So we're going to put restriction. So let me show you how to put the restriction. Backslash. I put a backslash. Y is greater than or equal to 2. So how do we read this? So I read it, y belongs to all real value, all real numbers, where y is greater than or equal to 2. I'm lazy to write that in words, so I say y is greater than or equal to 2. Did you see that? Everyone see that picture? All right. So as I don't know, so I still need to do that on my own line because it's recorded, but I can go back to my book. It's okay. So do you guys see how to state the domain and range? Hello, Baunavi? Hello in that so far? Okay, let me see where I am in my handout.
But what does this say after the range where you put the
Which one?
is that like a slash and then y?
Oh, greater than or equal to 2. Greater than or equal to 2. Okay, so that's page 1, the one organize that. All right. So what we're gonna talking about, guys, You learn quadratic function, you learn linear functions in grade 10. So I'm going to introduce some new functions in grade 11. My first function is called reciprocal function. Reciprocal function. How the reciprocal function will look like is simply f of x is equal to 1 over x. F of x is equal to 1 over x. So Barnaby, what is 1 divided by 0? 1 divided by 0 is 0. Do you have a calculator? Do you have a mobile device? Take it out and find out what is 1 divided by 0. Do you have a calculator phone? What is 1 divided by 0 there?
Check.
Yeah, check it. What is 1 divided by 0? So what is not working? So 2 iPhones are broke. What did you get? Math. Did you buy it in the Chinese market? How about you, sir? What? Okay. So we cannot divide a number by 0. So you all agree with that? So, okay. Now, but that's not the case. We're going to talk about that. So I'm going to sketch the graph. So how the graph is going to look like. So let's put some values to graph it. So I'm going to have an x value and y value. So let's start from -2, -1, 0, 1, 2 to graph it. So you all know it's going to be 1 divided by -2 is -0.5. 1 divided by -1 is -1. 1 divided by 0, undefined. We'll talk about how big is that later. 1 divided by 1 is 1. 1 divided by 2 is 2, isn't it? I mean, 1 divided by 2 is 1/2, 0.5. Okay, so first I get. Okay, guys. Now let me do 1 divided by. I'm not going to divide it by 0, but I'm going to divide it by really, really, really smaller number. 0.00000000000000001. Who want to do the division on your calculator?
I'll do it.
Okay. 1 divided by 0.000000001. That's enough, sir. Tell me, what did you get?
Aaron.
You got an error for that one.
So I missed.
Hello? Yeah. Class in 1:30, 11:30 to 1:30. Yeah, sure. Sure. What do you got, sir? You got an error?
Yeah. I think because I typed too many zeros.
That's true. So I'm gonna put like 1 divided by 0.0000001. Okay, I got something like that. Did you guys see there's a really large number? Does everyone agree that there's a really large number?
Yeah.
So when you divide it by 1 by really smaller number, this is going to be 1 isn't it? We call this number as going to infinity. As close to infinity. Do you know where infinity is? Do you know where infinity? Do you know where infinity is?
In between every number.
In between every number, so you can locate the infinity?
No.
Can you go and touch it?
No.
But there's a one person know the infinity. Who's that? Who's know the infinity? So I always keep on how people keep gold in their business. I keep in people that plays an important role in mathematics on my frame. So I have Brahmagupta sitting on the top. And if you go and see it, there's another brown guy sitting on the top, but he see the infinity. Yes. Ramanujan. Ramanujan Srinivas is an Indian mathematician, lived only 32 years old, born in Tamil Nadu. So he was born in the First World War time. He will sleep until in a Goda's Aman temple. So Goda's temple, they call it. In the morning, he will wake up and write equations. And then people ask him, how do you know this equation? He never went to school, no proper education. But he write a very complex mathematical formula. It worked out to be true. He said the goddess came in, the dream, and wrote things on my tongue, so I remember it. No one recognized this work. Nope. Couldn't able to find a job because he can't stay in a job. In First World War time, a professor from Cambridge, London, England, heard about Ramanujan. He sent an invitation to him. No flight, so he got a ticket on the ship. So he took the ship all the way up to England, 2 months trip. So he landed in England. And then he knows he's the only one can solve one of the unsolved puzzle called partition theory. It's been used in computer science a lot. Partition theory is basically how would you rewrite any positive integer as a sum of other positive integer. For example, if you get 1, you can write as 1 as 1. 2, I can write 1 plus 1, I can write 2, isn't it? 3, I can write 1 plus 1 plus 1, I can write 1 plus 2, I can write 3, isn't it? The question for him is, if you have a 10, how many different ways you can write? You can write 1 plus 1 all the way up to 10, 1, isn't it? 1 plus 1 plus 8 ones, and you can do 2. But how many of those ways are possible? Can you calculate? Not easy. It is not a pattern. It is not 10 times. For 1 is 1 time, 2 times, 3 times, but 10 is not 10 times. But Ramanujan gave an exact formula to calculate that. So he wrote it so hard, he asked him, I need a proof. Otherwise, it's useless. He said, no, I don't write proof. He forced him to write a proof. And he was awarded one of the best mathematicians award in England. It's called the Royal Society of Mathematicians Award for his work. His work plays an important role in computer science. So if you want to learn computer science further, numerical analysis is a huge concept that do all the sort of high-level computation, the AI using, machine learning using it, all these formulas this guy invented. So there's a book in his name talking about his biography. It goes by The Man Who Know the Infinity. And I'm not going to tell how he know the infinity, but we don't know the infinity. That's all about it. We're not Ramanujan. So I'm going back to sketch the graph, how the graph would look like. So let's sketch the graph. Well, I can show you how the graph looked like on my Desmos, but I'm going to show you how to sketch the graph. So we're going to do some rough sketch. So at 0, it goes to infinity, isn't it? I'm not going to mark it. At 1, what do you got? 1, 1, isn't it? Does everyone see that 1, 1 is a point? At 2, what do we got? 0.5, isn't it? So at 2, I'm going to mark it 0.5. So far, so good. At -1, I got -1. So this is -1 at -1. And then -2, I got -0.5, isn't it? At 0, where does this go to? Infinity, isn't it? So where is infinity? Infinity is here. Where is infinity? Negative directions? Here. So how the graph is going to look like, guys? The graph is going to be a smooth curve, goes like this. It is never going to be touch the x-axis or y-axis. And on the other direction, it's going to go like this. It's never going to touch the x-axis or the y-axis. Do you guys see that? You don't see that? So a reciprocal graph or reciprocal graph function can model so many functions. Example, if you keep a coffee cup in a room temperature, its temperature is going to be cooled down, isn't it? But it's not ever going to 0. Do you think that temperature will become 0? No, it's going to keep on cool down because at some point it's going to remain at the room temperature, isn't it? So it's going to be reciprocal. You start at 100 degrees Celsius, it's going to keep on decreasing, right? So there's a lot of phenomena can be described by the reciprocal function. Now we're going to tell the domain and range. Are you guys ready? Domain. X belong to real. But can I have a value of x is 0? Can we have a value of x to be 0 for this function? Can this graph take x to 0? Do you guys see a broken calculator? You cannot divide it by 0, isn't it?
Yeah.
So restriction applied for the domain. X cannot be 0. Are you seeing that? How about the range? Well, y belong to real, but the y never going to be like 0. Do you guys see the graph going, keep on going? It's never going to touch it, isn't it? This thing is going to touch the y-axis? No. So y not equal to? Everyone see the picture? Yes, no?
Yeah.
Okay, cool. Which is great. So I'm gonna introduce the next graph. So I'm introducing the key graph that you're gonna learn next week. Your teacher is gonna cruise through every day. So the way I teach at school, I teach in 1.1, 1.2, next day 1.3. So we start the school on Tuesday. On Wednesday, I teach 1.1, advanced function, 1.2 on Thursday, 1.3 on Friday, 1.4 on Monday, review on Tuesday, Wednesday. So at school, teacher can go through every session per day. And some teachers might go through more than one session. So those who are not taking math this semester, you're lucky. Otherwise, it will be cruising through. You have a non-semester or semester?
Non-semester.
Oh, that's good, sir.
Yeah.
You good, you survive. So I don't think so they're gonna come back to that until we meet again. Okay, but for you, she's gonna cruise through. She or he? Okay, they're gonna cruise through. All right. Now we're gonna go talking about the next graph. The next graph is square root function. Square root function. So how the square root function look like? F of x is equal to square root of x. Right? So can you find out what is square root of negative 16, sir, on the calculator? Square root of negative 16, okay? Not positive 16, negative 16.
There.
Okay. So can we have a negative value for the square root? No, we don't. But how the graph is going to look like, let's think about the graph. So x value, y value, 0, 0, 1, 1, 4, 2, 9, 3. I mean 9, 3, yes. Because square root of minus 3, isn't it? Let me have a rough sketch. Let me have a rough sketch of this guy. This is x, this is y. 0, 0, 1, 1, isn't it? 2, 3, 4. 4 is 2. Well, I'm not going to roll a 9. I don't have enough space. But you can see that shape of the curve. It's going to go like that. Did you guys see that? Yes? That curve is going to go like that, isn't it? So this graph is going to keep on increasing in y value, isn't it? When you go from left to right, the y values are keep on growing, isn't it? So let me see the domain. What's the domain? X belong to real, right? X must be greater than or equal to 0. Did you guys agree with that? All my x value must be positive, isn't it? Can I have a negative value for x? Can I have negative x value? Can I have x is negative? No, because your calculator is going to be China's calculator.
Yeah.
Well, I don't want to be racist at school. Okay. Range. I don't think so that's racist. Everything is made in China. So
Wait,
I went
did I say 149?
149, yes.
Okay.
I went to the bank. They have a pen. So I love the pen. I say, where did you guys get the pen from? They say, we got the pen from Temu. And then the person, the teller says, this is the only thing that's working from Temu. All right. All right. Now, y belong to real. And you guys see all the y values are positive. Do we get a negative y value?
No.
You start our origins, go this way, isn't it? All the y values are greater than or equal to?
0.
So what we're going to learn next class is we will do a lot of practice to do domain and range. But here's what we're going to talking about. You guys see the basic graphs. I talk about linear function, quadratic function, square root function, reciprocal function, isn't it? There's a one more function you're going to learn, pretty straightforward. It's called absolute value function. We'll discuss next class. But what exactly you're going to learn, or what you're going to learn, is a question by the turn on the lights. All right. We talk about how to tell the domain and range for y is equal to x squared, isn't it? Pretty straightforward. So you guys know that domain and range. But what we're going to learn is, we're going to transform this graph to x squared. Y is equal to 2 times x minus 2 whole thing squared plus 3. So what we're going to learn
we're gonna have a parent function. So we talk about basic graph. But we can transform this graph. For example, your square root graph can be shifted upward, can be reflected on the x-axis, can be reflected on the y-axis, can be reflected on the x-axis, y-axis go down. The same square root graph can be transformed into like this, right? But the question here is, if I transform the graph, how would you tell the domain and range? So you guys see that the graph goes like that, right?
Yeah.
Now all the x values are negative. Did you guys see that? It doesn't have any positive x value. Right?
Y values.
Y value is also negative, isn't it?
Yeah.
You see the completely changed. So what the challenge you guys gonna see the next unit is 1.4, 1.3 is 1.3 is what I talk about today, parent function. I talk about the parent function, pretty much all the function I talk about, except that I didn't talk about that function f of x is equal to square root of x. And in absolute value of x, 1.4 transformation and domain and range. So that's a huge unit. You might learn that at school, you might not, but you got the idea. The setup is done, domain and range. So when your teacher introduces notation, you won't be worried about it. But transformation, something that we're going to talk about next class. That's what it is today. So you're going to be look at the textbook 1.1, 1.2, 1.3. I have done it. And look at all the questions from the textbook except the extending questions. The rest of the questions you can find. All right. Super second. Well, for you three, I had for you. We might you got the idea. You didn't go to 1.2 and 1.3. But next class when you come back, I feel your teacher might almost finish chapter 1, or they say, you know what, chapter 1 quiz is coming up next week. But we're on track. All right, so you guys are dismissed. So you need to join the Google Classroom to do the homework questions.
Okay.
To access the textbook.
Go ahead.
You can join it, but you also have the textbook, right?
Oh yeah.
Then both you want to
Use that, right?
yeah, you choose the textbook. You buy it outside?
Got it from my school.
Or they sell the all
Yeah.
the books, okay. You're in a Brandon?